Good morning, good afternoon, and good evening. Mr. Parisi bringing you Unit 7, Factoring Day 2. Today we're going to be talking about my greatest common factor, also known as my GCF. To factor just means to split a number into its parts. So as an example, if I had the number 6 and I wanted to split it up into its parts, I know that 2 times 3 equals 6. So since 2 and 3 multiply to give me 6, those are my two factors. My GCF factored answer will be written using the distributive property. And one last rule of thumb today is what is divided out goes in front of the parentheses for the final factored answer. We'll talk more about that as we proceed with the lesson. For question number 1, we have 5a squared minus 15. Now when we're factoring, we're looking at what the terms have in common to see what we can pull out. To start, we always look at our coefficient. So my coefficient on the first term is a 5, and my coefficient on the second term is a negative 15. The biggest number that goes into 5 and negative 15 is 5, so I know I can divide out a 5 from both of these terms. Next, I look at my variables. I have an a squared on my first term, and then I don't have a variable on my second term. So in this case, I can't pull out anything with my variables. They don't have anything in common between these two terms. So we wrote up top, whatever we're dividing out, we write in front of my parentheses. So I'm going to write my 5 out front and then just simplify the expression. So 5a squared divided by 5 gets me a squared. Negative 15 divided by 5 gets me a negative 3. We did write this using distribution, so if I were to distribute this 5 back in there, I would end up exactly with what I started with. It's important to realize that when we factor something, we're not changing the value of it, we're just writing it in a different form. We can treat question 2 in the exact same manner we treated question 1. To start, we look at our coefficients. My coefficients in this case are 48 and 36. The biggest number that goes into both 48 and 36 is 12. So I know I can pull out a 12. Next, I'm looking at my variables. Let's start with the x's. Here I have x squared in my first term, and then I have x to the third in my second term. The most x's that I could possibly pull out of here are 2, because that's all my first term has to offer. So x squared I could take from both terms. And lastly, I look at my y's. I have one y here and 2 y's in the second term. So the most I can possibly take out is just 1. So in this case, my GCF ends up being 12x squared y. Now whatever I'm dividing out, whatever my GCF is, I write in front of my parentheses, 12x squared y. And then I simplify my expression. So 48 divided by 12 gets me 4. My x squared divided by x squared cancels. My y divided by y cancels. So I just have 4 for my first term. Plus 36 divided by 12 gets me 3. X to the third divided by x squared gets me an x. And y squared divided by y gets me a y. I've successfully simplified and factored this expression. Be sure to try the 2 problems on the right side of your page on your own. You'll notice that number 3 looks like it's written a little bit trickier. It's a little bit tougher to see. However, I have 2x times x minus 4 as my first term, and then I have x minus 4 as my second term. Even though we can't see it, we should know that there is a 1 in front of that parentheses. So to start, I'm looking at just what's in front of the parentheses in both of my terms. I have a 2x and a 1. There really isn't a common term that goes into both of these aside from 1, which we really don't need to write for my GCF. Next, I look at inside my parentheses. I have an x minus 4 and I have an x minus 4. We should see that this is common between both of these terms, so I'm actually going to be able to divide out my x minus 4. That makes this my GCF, because both terms have x minus 4 in common. So my GCF is x minus 4. Now whatever my GCF is, we always pull out front. Whatever we're dividing out, we put right out front. So x minus 4, I'm going to keep that in parentheses. And then we look at what we have left over. So you'll notice up top, my x minus 4s are going to cancel here, and I'm just left with a 2x. And then the same thing happens on the other side. My x minus 4's cancel, and I'm just left with a plus 1. So I'm going to write in my plus 1. That's what it simplifies to. So my factored answer is going to be x minus 4 times 2x plus 1. And remember, this was my GCF. That's what both terms had in common that I was able to pull out. Try number 3 on the right side of your page on your own. Question number 4 says the area of a rectangle is represented by 3x squared plus 6x, and the length by x plus 2. Express the width of the rectangle in terms of x. I'm going to start by just writing down what I'm given. So the area is represented by 3x squared plus 6x. So A equals 3x squared plus 6x. And it tells me that my length is x plus 2. So L equals x plus 2. What we're looking for in this problem is my width, which we don't know, but we want to express it in terms of x. So I'm just going to write W equals and leave that blank. That's my question mark. That's what we're trying to solve for. I should know that the area formula for a rectangle is area equals length times width. So substituting into this equation, I know my A equals 3x squared plus 6x. That's going to equal x plus 2 times my W. If I look at the left side of this equation, here's where factoring is going to come into play. What do these two terms have in common? Let's start with our coefficients. 3 and 6. The biggest number that goes into 3 and 6 is 3. So I know I can pull out a 3 here. I'm going to divide out my 3, divide out my 3. I'm just factoring. And then I look at my variables. I have an x squared and an x, so the most that I can take out is 1x. When I pull out my GCF of 3x, I write it right out front, so I have 3x times what I have left over is just x plus 2. Okay? So all we did was rewrite that left side. We weren't doing any inverse operations or anything like that. We were just factoring the left side to make it look a little better for us, so we could use it. And then on my right side, I still have x plus 2 times w. In order to solve for w, all we have to do is clear that side out, so we have to move that x plus 2. Now, since x plus 2 is connected with multiplication to this w, the opposite of multiplication is division. So we're going to divide out x plus 2 and divide out x plus 2. The x plus 2's cancel, and I'm just left with w. Over here, same thing. X plus 2's cancel, and I'm just left with 3x. I've successfully written my w in terms of x, so I now know what my width is. Be sure to complete all the practice problems that you were supposed to do on your own for class tomorrow. If you have any questions, bring them to class.